Hey folks, welcome to my channel number 10. So there we have the problem on the screen. Integrate the following with respect to x. We have x cube sine x, right? What we have been given is dy by dx and we've been asked to find y. So my y is nothing but integral of the given expression. So let's write down what is our y. So that's my y. Now it looks like I'm not in a position to solve this by the method of substitution. But then my y is of the form integral of u dv, right? So we know how do we go about solving an integral of the type u dv? We will apply integral by parts. And let me write down what is my integral by parts. My integral by parts states whenever I have an integral of the type u dv, then my u dv equals uv minus integral of v du, right? Now, like we saw in our earlier videos, whenever we have an integral of the type u dv and x to the power n is one of the expressions within u dv, then we go ahead with u equals x to the power n, right? And in this particular case, I see that I have an x cube, right? So my u will be equal to x cube and my dv will be equal to sine x dx, right? Well, pause here for a minute. I know that when I expand this using integral by parts, my integral of v du, which is the second part of the RHS, will still not be in a format whose antiderivative I will know from first principles, right? So, which means we will have to apply integral by parts successively, right? Now, I want to draw your attention to a video where I discussed Bernoullis integration by parts. And I'm not going to apply integration by parts successively in this particular problem. Rather, I'm going to apply Bernoullis identity to this particular integral and solve this problem for you, right? So let's write down what is my Bernoullis integral by parts. So there we have the Bernoullis integral by parts, and let me give you a link to the Bernoullis integral by parts video in the description. I request all of you to take a look at it. So my integral of u dv equals uv minus u dashed v1 plus u double dashed v2 minus u triple dash v3 plus integral of v3 into u dash 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 dash, right, times dx. So it is the fourth successive derivative of u, right? So my dash represents derivative and my subscript 1, 2 and 3 represent the successive integrals of v, right? So like we usually do in our integral by parts, I will have to choose my u and dv, which we have already done. Now, to directly arrive at an answer, I need a couple of other answers, right? So what are they? I need my u dashed, u double dashed, u triple dashed, okay, and I need my v1, v2 and v3, right? And what else? So let's calculate this. Let's work out our successive derivatives and successive integrals of u and v respectively, and let's see what do we get before we go to the next step towards solving this problem, right? So I'm going to use this line for my u. So when my u is x cube, right, what is my u dashed? It is nothing but 3x square. And what is my u double dashed? It is nothing but 6x, right? And then I go towards my u triple dashed, which is 6, right? And then I go to my fourth successive derivative of u, which becomes a 0, right? So, which is where, this particular expression, let me highlight this in pink, right? This particular expression is 0, and I don't think we will have to expand my integral of u dv any further beyond the third derivative of u and the third successive integral of v. So I'm going to eliminate what I've highlighted in pink here. So this is what we have. And then I'm going to go to the next line and evaluate my v. My dv equals sine x dx. Therefore, my v equals minus of cos x, right? And what is my v1? My v1, this is where I want you folks to be a little careful here. My v1 is nothing but integral of v, right? And what is my v? It is minus cos x, right? And what is that? It is a minus of sine x, right? And then I go to my v2. My v2 is nothing but integral of v1 dx. And what is my v1? We just worked it out, a minus sine x dx, right? Minus sine x dx. And what is that? It's nothing but a cos x. And then I noticed that I also need my v3 here. So what is my v3? My v3 is nothing but integral of v2 dx, right? And what is my v2? It is cos x. And that's nothing but a sine x, right? So there we have our u dashed, u double dashed, u triple dashed, and we have our v1, v2, and v3, right? So I have all of what I want. I have my uv first. So I know that my u is x cube and my v is a minus cos x, right? Therefore, my uv is nothing but minus of x cube times cos x. Okay. And then I have a minus of u dashed into v1. I know that my u dashed is 3x square and my v1 is a minus sine x, right? So I will have this as a plus here, and then I get a 3x square times sine x, right? Then I have a plus u double dashed into v2. My u double dashed is 6x, and my v2 is cos x, right? And then I have a minus of u triple dashed, which is a 6, right? Into v3, which is a sine x, right? And then finally we bring in our constant, right? So the answer to this particular problem is minus x cubed times cos x plus 3x squared sine x plus 6x cos x minus 6 sine x plus c. Let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.